Today we're going to be working on another Amazon's interview question. This is Leetcode question number 53, maximum subarray. So basically we're going to need to return the sum of the maximum subarray. And again, uh, it should be understood that we are not supposed to change the location of we cannot sort it, we cannot change the indices or the position of any of the element inside the integer array. Otherwise it will uh, lose the purpose of actually returning the sum of the subarray. Okay, the algorithm goes like this, that basically you're gonna have two main things here. One is the result. Basically whenever this is gonna have the whenever index is gonna be running, it's gonna be iterating through the input array. It's gonna be iterating through the input array. The result is gonna keep record of the the maximum sum you have seen so far. So it's only gonna get updated when it sees a bigger sum. The other one is uh, we're gonna call it positive sum, and this is gonna keep accumulating just like the not just like the result. It's gonna keep accumulating when we are iterating through the array. It's going to keep accumulating all the new incoming elements as long as the positive sum is greater than 0. The moment it becomes less than 0, we're going to make it equals to 0 again. That would work. That's gonna gonna get us to the result. And yeah, so in terms of let's see at the snippet here. We have this result equals to the integer dot minimum value. We start this is a negative infinity at the beginning. Positive sum is equal to 0. We start with that. We're gonna be going through all the elements as long as this I positive sum is basically uh, first of all, we're always gonna be doing that. We're gonna say that okay, we add it to whatever the value of the positive sum is. So that's gonna make it sorry, what did I just do? That's gonna make it -2. But then we're gonna see that first of all we're gonna update our result. So whichever is bigger, so it's gonna get updated to -2, and then the last thing is we don't want to keep the negative in numbers. That's the gist of the logic here. If it is a negative 2, we're just gonna make it 0. Again, going here, we're gonna update it, which is gonna become 1. This is also gonna become 1, and then we're gonna say that uh, if it is greater than 0, that is well and good. We don't want to touch that. Again, going here, it is gonna become -2. This is not gonna get updated. This is we're gonna say that because it became less than 0, make it 0. Okay, going to the 4, we will have 4. We're gonna update that. We're gonna say that it is greater than 0, so let it be. -1, it's gonna make it 3. This is not gonna get updated, and we're gonna move it to the next one. 2 is gonna make it 5, and this is gonna get updated to 5. This is gonna move to the next one. This is gonna become 6. This is gonna become 6, and this is gonna move to the next one. Now this is gonna become 1. this is gonna stay 6, and this is gonna move to the next one. Look, we did decrease, but because it didn't go below 0, we did not make it 0. And then 4, which is gonna make it 5. Still, this is gonna stay the same. We have covered all the elements, and this is gonna be returned. In terms of the space complexity, we are not using any extra space. In terms of the time complexity, it's gonna be linear. If we have n number of elements, it's gonna take O of n. That's all I wanted to cover in this video. Thanks for watching.